Okay, in the theory of relativity, the Lorentz contraction formula says that L, which is the length of an object as viewed from the perspective of an observer, is equal to this L naught, which is the length of the object if it was at rest, times this here, which is the square root of 1 minus, so the velocity of the object squared divided by the speed of light squared. Okay? So first, this question asks us to find this limit. The limit as the velocity of the object approaches the speed of light from below of this L, which is the length of the object as viewed from an observer. So the limit as the velocity of the object approaches the speed of light from below of L. Okay, so this is 1 minus. All right, so let's do this limit. So V is approaching C from the left. All right, so let's plug this in. Here's your V. So V is getting closer and closer and closer to C from the left. But I guess if it was from the right, since it's a squared, it wouldn't matter either way. But just even coming from the left, this term here is going to be approaching C squared. Okay, that means that this entire term here is going to be approaching 1. So so this entire radical here, this square root of 1 minus 1 is approaching 0. So as V approaches the speed of light from the left, this is going to be an infinitesimally tiny number. Infinitesimally tiny number times L naught is just another infinitesimally tiny number. So this is approaching 0, this limit. Now, if it was just in general, not from the left or the right, I think it would still be the same because this is V squared. So even if, when you think coming from the left or the right, you think that negative terms could come into play. Well, actually, okay, yeah, so this V wouldn't be negative, but if you could go, if you could come from the left or the right, you would have something that's greater, the V squared would be greater than C squared, so you'd get a negative in this root. So that's just how you would analyze it in general, but this problem, you have to come from the left, and we'll talk about that in a second. But this limit here, coming as V approaches the speed of light from the left, is equal to 0. Okay, so interpret this result. What this is saying is that if something is traveling at the speed of light, then from the perspective of an observer, you can't see it. Okay? Now, why is a left-hand limit necessary? So you couldn't put just a general limit or limit coming from the right because nothing can exceed the speed of light. So you have to put, as far as this formula is concerned, you have to put a left-hand limit.